In this video, I want to take the derivative of sine and show you that it really is cosine using the definition of derivative. Y is equal to sine x, so y prime is the limit as h approaches 0 of the difference quotient. So I'm going to need to work on simplifying this difference quotient so I can cancel that h off at the bottom. On this next board, I have a couple things that are going to be helpful. Over here, I've written the sum and difference formulas for sine and cosine. For the problem we're working right now, we only need the sum formula for sine. We're also going to need to know how to evaluate these two limits. This first limit's one of the first limits we ever saw. The limit as h approaches 0 of sine h over h is 1. We might be used to seeing that with a theta in those spots or an x in those spots, but variable names don't really matter. And then we're going to need to know what this limit's doing. So let's see if we can work through it. I'm going to multiply the top and the bottom by the trigonometric conjugate. On the bottom, I'm just going to write those two things down next to each other. I'm not going to distribute because I'm trying to cancel that h off after all. All right, and then on the top, I'll distribute, and I'll get 1 minus cosine squared of h. 1 minus cosine squared is the same thing as sine squared. That's a fact due to my Pythagorean identity. And then h times 1 plus cosine of h. All right, let's see what I can do with this limit. The limit as h approaches 0. And on top, I have sine times sine. So I'm going to split that into two fractions multiplied together. Because I know where this limit's going. As h goes to 0, sine of h over h is going to 1. That's that limit we know there. All right, let's think about this limit. As sine of h as h goes to 0 is going to 0. On the bottom, I have 1 plus cosine of h. Well, cosine of h goes to 1. 1 and 1 make 2. So I have 1 times 0, which is 0. So this limit that I started with, 1 minus cosine of h over h is going to 0. Now that we have that limit, I actually need this one. I need the order on top in the subtraction to be reversed in a moment, but what I'd say is that's literally the opposite. So if I multiply 0 by minus 1, I still get 0. All right. I have my addition formula for sine. The sine of alpha plus beta is sine of alpha times cosine beta plus cosine alpha sine beta. And I've been able to establish the limit I was after. So let's see if we can use all of this together to prove that the derivative of sine really is cosine. So what I'm going to do first is I'm going to look at the sine of x plus h, treating x as alpha and h as beta. So limit as h approaches 0 of the sine of x times the cosine of h plus the cosine of x times the sine of h minus sine x, all still over h. Well, when I look at those things, I see one pair of things that I might be able to do something with. So I'm going to write the things I'm putting in a rectangle now. I'm going to write them together. So right now I'm just rearranging my equation. Rearranging my limit, better said. So I have the sine of x times cosine of h minus sine x plus the cosine of x times the sine of h, all over h. What I'm going to do now that I've written these things next to each other is factor out that sine x. This term I'm going to leave alone, and everything is still being divided by h. So what I want to do now is rewrite this as two fractions being added together by just dividing each one by h. And I'll tell you what, to save a little space here, instead of dividing by h. I'm going to multiply by 1 over h. That's always the same thing, and it'll help me manage my tiny board space here. All right, so there I have a limit statement, and I'm going to rewrite it slightly. Just rearranging my terms. I have three things being multiplied together, so I can rewrite them like that. And the same thing here. And if I think about my limit laws, I could take the limit of this part and this part, the terms separately, the addition law. If I think about my product law for limits, I can take the limit as h approaches 0 of this and this independently too. Well, all of that to say that, the limit as h approaches 0 of this part in parentheses is, well, that's what we worked out earlier, right? That's what's in this rectangle. The cosine as h approaches 0 of cosine h minus 1 all over h is 0. So this limit here going to 0, 0 times sine of x is 0. That whole first term is going to 0. This term, the limit of sine h over h as h goes to 0 is 1. The limit of cosine of x is, well, cosine of x, there's no h in it. And so I just get cosine of x. And so the derivative of sine really is cosine. So we have done it. We have proved that the derivative of sine is in fact cosine. Okay, so I'm going to leave it as an exercise for you all to prove that the derivative of cosine is minus sine. And everything you need is here and in this video. These two limit statements, the addition and subtraction formulas for cosine, and the definition of a derivative. Give it a try on your own, and let me know if you have any questions.